What is going on, everybody? So today I got to talk about inheritance in Python. Inheritance allows a class to inherit the attributes and methods from another class, much like how a child in real life can inherit traits from a parent. By having a class inherit attributes and methods from another class, this helps with code reusability and extensibility. In this example, we're going to create an animal class. The dog, cat, and mouse class will inherit attributes and methods from the animal class. We will create a class of animal. Then I will define the constructor. When we construct an animal object, let's pass in a name. It's not required, but it might be good for this example. We will assign the attribute of name equal to the name we receive. Let's also add an attribute of is alive. Whenever we create an animal, we will set their isAlive attribute to be true, and that is a capital T. All animals can eat. Define eat. We will print, using an f-string, add a placeholder, self.name, the name of this animal, is eating. All animals should be able to sleep. Define sleep. Print, I'll use an f-string, insert self.name is sleeping. And that is all we need for the animal class. Let's define class dog. For a child class to inherit the attributes and methods from another class, after the class name that's going to inherit, we need to add an inheritance list with a set of parentheses, then list the name of the class we're inheriting from, the parent. The dog class is going to inherit all of the attributes and methods of its parent, animal. For the time being, as a placeholder, I'll add pass, just to demonstrate this. Class cat is also going to inherit from animal. And class mouse will also inherit from animal. Okay, I will collapse this for now. We'll create a dog object, dog equals dog, then pass in a name for this dog, because we have one parameter set up of name. This dog will be named Scooby, as in Scooby-Doo. Cat equals, call the cat constructor. This cat will be named Garfield. And mouse. Mouse equals mouse. Our mouse will have a name of Mickey. Even though there's nothing within this dog, cat, or mouse class, we should still have these attributes and these methods. If you inherit the animal class, you should have a name attribute, an isAlive attribute set to true, you can eat, and you can sleep. Let's print our dog's name. Dog.name. Scooby. Print dog.isAlive. Our dog is alive. That is true. Let's have our dog object use the eat method. Scooby is eating. And sleep. Dog.sleep. Scooby is sleeping. Let's replace dog with cat. The name of the cat is Garfield. Garfield is alive. Garfield is eating. Garfield is sleeping. And mouse. Replace any instance of cat with mouse. Our mouse's name is Mickey. Mickey is alive. Mickey is eating. Mickey is sleeping. Even though these children classes are empty, we're still inheriting these attributes and methods from its parent, of animal. This is convenient because you don't need to copy and paste these attributes and methods for every single class. For example, if I were to copy these attributes and methods and paste them, well, we have a lot more code to write. And as a consequence, if I need to make a change to one of these methods, I would have to do that to every single instance of this method. For example, let's replace is sleeping with is asleep. Well, now I need to find every single sleep method and change it manually. It's not too bad if you only have a few classes, but imagine if you have hundreds of classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change is sleeping to is asleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak. Let's have our dog speak. Woof. Let's have our cat speak. Meow. And our mouse. Squeak. Alright everybody, so that's an introduction to inheritance. Inheritance allows a class to inherit attributes and methods from another class. Much like in real life, a child can inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. And well, everybody, that is an introduction to inheritance in Python. Hey everybody, so today we got to talk about both multiple and multi-level inheritance. We'll begin with multiple inheritance. That's when a child class inherits from more than one parent class. For example, a class of C can inherit the traits from both class A and B. In Python, you can have more than one parent. Multi-level inheritance, we'll talk about near the end of this topic. So in this example, we're going to create two parent classes, prey, I'll write pass for now, and predator. We'll create a class of rabbit, a class of hawk, then class fish. Rabbit, hawk, and fish are going to be children classes. Prey and predator will be parents. If one of these classes, rabbit, hawk, or fish, inherit from prey, they get the ability to flee. We will define a method of flee. All we'll do in this example is print the following text. This animal is fleeing. If you're a predator, you get the method to hunt. Define hunt. We will print this animal is hunting. Rabbits, they will inherit from the prey class. They're typically not predators, except that one rabbit in Monty Python and the Holy Grail. That's the exception. Rabbit will inherit the prey class. Then it gets access to a flee method. Hawks are predators. They will inherit the predator class. Now fish, they will hunt smaller fish and flee from bigger fish. You could consider fish both prey and predators, so they will inherit both classes. We will use multiple inheritance. They will inherit everything from the prey class and the predator class. Now let's see if this does in fact work. Now we'll create a rabbit object. Rabbit equals rabbit. There are no parameters set up. We don't need to send any arguments to the constructor. Hawk equals hawk. And fish equals fish. So let's take our rabbit object, and they should have a flee method. Rabbit.flee method. This animal is fleeing, but they do not have a hunt method because they're not predators. Rabbit object has no attribute hunt. Hawks can hunt. They're predators. They inherited that method. This animal is hunting, but they can't flee. They're not prey. Hawk object has no attribute flee. Fish can do both. They inherit from the prey class and the predator class. fish.flee. This animal is fleeing. Fish.hunt. This animal is hunting. Children classes can inherit from more than one parent, which is what we did for fish. They are both prey and predators, whereas in rabbits are just prey, hawks are just predators. If you need to inherit from more than one parent, you just add that additional class to the inheritance list. With multi-level inheritance, a parent can inherit from another parent. We will create a class of animal. And for now, I'll write pass. Prey and predator are going to inherit from the animal class, so we need to add animal to each inheritance list. Let's say if you're an animal, you get a method to eat. All animals will eat. Print this animal is eating. And you can sleep. Define sleep. Print this animal is sleeping. So think of rabbit, hawk, and fish as children classes. Prey and predator are those classes' parents, and animal is the grandparent. Prey and predator will inherit everything that the animal class has. Rabbit, hawk, and fish will inherit everything the prey and predator classes have. So now our rabbit, hawk, and fish classes should have the ability to eat and sleep, and we'll test that. Rabbit.eat. This animal is eating. Rabbit.sleep. This animal is sleeping. Let's check out fish. Fish.eat. This animal is eating. Fish.sleep. This animal is sleeping. Okay, we're going to expand upon our example a little bit. Let me zoom out. Each of our objects is going to have a name. Our rabbit will have a first name of Bugs. Hawk will be Tony, as in Tony Hawk. Our fish will be Nemo. Within our classes, we don't have any constructors set up. In which class should we assign the name attribute? Let's do so within our animal class. So we will define a constructor to assign these attributes. We will receive a name. We'll assign self.name equals name. Now with these other classes, if you're not assigning any attributes, or if you don't need any other initialization logic, you don't need a constructor. We'll implicitly use the constructor we inherit from the parent. Let's convert each of these print statements to an f-string. Replace animal with self.name. Now let's have our rabbit use the eat method. Oh, we should get rid of this. There we go. Bugs is eating. Rabbit.sleep. Bugs is sleeping. Rabbit.flee. Bugs is fleeing. Let's check out our hawk. Hawks don't have a flee method because they're predators, not prey. Let's eat. Tony is eating. Let's sleep. Tony is sleeping. Let's hunt. Tony is hunting. Let's check our fish next. Our fish can eat. Nemo is eating. Our fish can sleep. Nemo is sleeping. They can flee. Nemo is fleeing. And hunt. Nemo is hunting. Okay, everybody, that is both multiple and multi-level inheritance. With multiple inheritance, a child can inherit from more than one parent class. You just add each additional class to the inheritance list. With multi-level inheritance, a child can inherit from a parent, which inherits from another parent. Class C can inherit from B, where Class B inherits from A. Think of C as the child, B as the parent, and A as the grandparent. C will have all the attributes and methods, even available within the grandparent class of A. And well, everybody, that is both multiple and multi-level inheritance in Python.